So the last thing I want to check is significant figures. In the problem, I was given 1, 2, 3 sig figs, and that's the only measured value I use, so I should end with 1, 2, 3. And I'm going to box my answer to make it final, and you're finished. Although it's a terrible box, you are finished. Okay, problem 3 has to do with density. So, problem 3 says, suppose a boat engine leaks 938 milliliters. So I have 938 milliliters of oil into a lake. So I pour it into this lake. So now there's oil. This is oil. And it says the mass of this spilled oil is 823 grams. The oil will not mix with the water, so mixing, no. Will the oil sink or float? So will it go down, question mark, or will it stay on top? This is a problem of density. So I'm going to write our density expression, which is D equals M over V. This is mass per unit of volume. So if you remember, the lower D will go to the top of the lake. So if the density of the oil is smaller than the density of water, then it will go to the top. If it is larger than the density of water, then it will go on the bottom. Pretty simple. Okay, so that means I need to know two things. I need to know the density of water and the density of oil. So the oil, I have all of the numbers to actually calculate the density of oil. So I'm going to take my mass, which is right here, and my volume. So if I take my mass, which is 823 grams, over 938 milliliters, I will get, let's see, 823 divided by 938. Both of them are 3 significant figures. Just keep that in mind. I will get 0.877. 0.877 grams per milliliter. Now water has a density of about 1.00 grams per milliliter. You should know that. So I'll put a little star. You should know this for the exam. That means the oil will float. It'll go on the top because the density is low. Okay, the last problem for this video is problem number 7. This has to do with thermal heat and specific heat capacity. So you're given a table of specific heat values below. What is the identity of a 10.0 gram metal sample that increases by 14 degrees Celsius when 62.9 joules of energy is absorbed? So let's write down all of these values. I know my mass. Oops, hold on here. I know my mass is equal to 10.0 grams. My change in temperature, so in the problem it said increases by 14.0 degrees Celsius, so you want to pay attention to the words. The words say increase by, so that just means the change in temperature is 14.0 degrees Celsius. And last, it gives me the energy absorbed, and we know we're looking at heat here, so that gives us Q. And absorbed means it's positive, so I have a positive value of 62.9 joules. Okay, that should bring to your mind a specific equation, which is Q equal MCAT. Q equals M times C times delta T. So all you're trying to find out is this value right here, your C. You have all other values, so you can plug those in. So for Q, I'm going to plug in 62.9 joules equals my mass, which is 10.0 grams, times my C, which I don't know, times my delta T, which is 14.0 degrees Celsius. That will give you a value. If I multiply these together and then divide by their value on both sides, it will give you a value of C that is equal to 0.449 joules per grams times degree Celsius. So you want to check that your units work out correctly, because I will be checking your units. You have joules, and that's going to be divided by a gram in Celsius. So your answer is correct with the correct amount of significant figures and the correct units. So the identity of the metal should have given you iron. And yes, you do need to know the name and the symbol for iron.